is Matthew Looney, and I'm here tonight to teach you about the Pythagorean Theorem. The Pythagorean Theorem was developed in order to find the lengths of the sides of a right triangle. Like I said, it can only be used on a right triangle, and you have to know two of the side lengths in order for it to work. The formula for this theorem is pretty simple, as it is a squared plus b squared equals c squared. Now your a and your b are going to be your legs of a triangle, which are the two sides that are perpendicular and also have a right angle with them. So these would be your legs, and your c would be your hypotenuse. The hypotenuse is always the longest side and always opposite of the right angle. So if I was to apply this formula to this triangle just with the letters, this would be A, this would be B, and this would be C. Now, for an example on how to really use this. Say I have a triangle, that's a right triangle, and I knew that this side was 3, this side was 4, and I didn't know what C was, so we'll just leave it as C. I would apply this formula. So you take your a squared plus b squared equals c squared, and you apply what you know. Your a is 3, so you plug in a 3. Your b is 4, plug in the 4. And as stated earlier, you do not know your c, so we'll just leave it as c squared. Now you apply the squares to the numbers. So 3 squared is 9, plus 4 squared, 16, equals c squared, which we still do not know. Combine your like terms, you have 25 equals c squared. But you're not done yet. We're looking for c, not just c squared. So in order to find what c is, you just take the square root of both sides, which would equal 5 for c. So the hypotenuse of this angle would be 5. Simple enough. Now say you had a triangle that you knew one side and the hypotenuse but not the other side. Can we still use this? Yes. We'll do an example. So I have a triangle where I know the hypotenuse is 13, the side is 5, and b is unknown. Take your formula, a squared plus b squared equals c squared, and plug in what you know. A is 5, you have 5 squared. You do not know what b is, so you leave it as b squared. And your c is 13, so it would be 13 squared. Apply the squares to your numbers. 5 squared is 25. Still do not know b squared. 13 squared is 169. In order to figure out what b is, first we have to get all the numbers on one side. So you subtract the 25 from both sides, and you end up with b squared equals 144. And just like earlier, we do not need b squared, we need b. So you take the square root of both sides, and you get b equals 12. So your side b on this would equal 12. Now, both of these examples I just used are special right triangles that they're numbers that are always consistent. And those two stipulations are 3, 4, 5, or 5, 12, 13. Now, any rendition of these numbers can be used. You can have everything by 2. So you can have 6, 8, 10, or 10, 24, 26. You can have any numbers as long as they are equivalent to 3, 4, 5 when they're simplified. Now that's just a side note, that's your special right triangles, and this makes things a little easier. So this is the Pythagorean Theorem. Simple formula of a squared plus b squared equals c squared. Apply it to your triangle, you have to know the two sides and it has to be a right triangle. And that's about it.